Well, good afternoon. Welcome to Algebra 2. My name is Mr. Royce. I'm going to be your Algebra 2 instructor for today. Let's begin our lesson on 5.7a. The homework is online. Just download the PDF of the worksheet for 5.7a. We're learning the three-box method today for completing the square. Several times during the lesson, you will draw triplets of boxes. Mine will always be green. The three-box method of completing the square. Let's jump into it. Notice that in example 1, unlike the work that we did yesterday where all the equations were in the form either y minus k equals a times x minus h squared, or we had added k to both sides, today we're going to start out with equations that are in the standard form. A is 1, b is 6, c is equal to 2. It's like, how can I convert the standard form to the vertex form of which we've grown so fond after using it to create models of reality? Well, let's do an example. OE is just an abbreviation for original equation. Let's get rid of the constant. Let's subtract whatever c is from both sides. So when you subtract 2 from both sides, it's my belief that you'll end up with y minus 2 equals x squared plus 6x. And now the triplets of boxes will be populated to complete the square. And by completing the square means we want to turn this binomial into a trinomial that can be factored into something squared. Because, I mean, isn't that what this is? This is a binomial squared. We want to convert that, a trinomial, into something squared. Now, the secret. I don't want to give you the impression that mathematics is all about a secret society where the only people who know what's going on are the initiated, people who have had the broad courage to endure the initiation ceremonies. No. Math is for everyone, not just the secretly initiated. So whether you've gone through the initiation or not, I want you to know that the first box is always B. A is 1, B is 6. First box is always B. And the second box will always be, oh, hey, Peter. Yeah, I know the creativity is just, the urge to create is so deep in human nature. It's hard to tear yourself away from that calculator and the opportunity to make mathematical models. But just for about half an hour, tear yourself away. We subtracted 2 from both sides. And now we're going to populate the 3 boxes. First box is always B. Second box is always half of the first box. And to find the third box, take whatever's in box 2 and square it. Actually, the whole strategy is mapped out. Square it. 3 squared is 9. You now have the triplet of boxes filled in. Now, for note taking, if you want to make a note to yourself, this first box is always B. A is 1. B is 6. The second box is always B over 2. B divided by 2. Third box is always B over 2 quantity squared. Okay, but that stuff in red, of course, you would never write on a test, or that's just for note-taking purposes. So let's make that go away. All right, now, those 3 boxes are a signal that it's time to add whatever the third box is to both sides. So help me out here. Please add 9 to both sides. So it's going to be y plus 7 equals x squared plus 6x plus 9. We've added box 3 to both sides. Our next move will be F, which is just an abbreviation for factor. We're going to factor this trinomial into something squared. So let's get over here so the other half of the room can see. It's something squared. This is a perfect squared trinomial because we've added box 3 to both sides. And did you know that the binomial will always be x plus box 2? Whatever's in the second box will be the factored form. So we did it. We put it in vertex form. Now, if you want, you don't have to, but you can subtract 7 from both sides so that it's a form into which it can be typed, or so that you can type it into the calculator. This is the form that is calculator ready. But the whole point is that now we can see, just like when we were creating models of the bridge, we can see that the vertex is located where. So this is something that Haley missed yesterday. So for Haley's benefit, let's just review what would the vertex of this problem be? Raise your hand if you think you know. Yeah, Haley, go ahead.
3,
Negative 3. Yeah, in fact, you can actually see it better here. It's negative 3, comma, negative 7. Same on both sides, as long as the same is in that you're watching the movie backwards on both sides. It's negative 3, comma, negative 7. So that's where we're going to plot it. Negative 3, comma, 1, 2, 3, 4, 5, 6, 7. And look out, where's golf ball negative 3? It's 7 feet under, 7 feet below ground. Humming a pleasant tune of defiance. Such a catchy tune. Makes you want to tap your foot, do a head nod. Defiance. People have never been here before. It's your first time here at Wheaton Academy. Don't even try to understand. So, someone might sit down and take a day to explain it to you. Now, so over 1 up 1, we got over 2 up 4. 4. Wow, we're so far down on the grid, we can do over 3 up 9. Actually, you can just piggyback off of 4. So once you got to 4, 5, 6, 7, 8, 9. Did I do that right? 5, 6, 7, 8, 9. So over 3. Can we do over 4 up 16? Let's find out. 10, 11, 12, 13, 14, 15. Can't make it up to over 4 up 16, but we got the rest. Any questions on how to do example 1? These do get a little bit harder. So, last call for questions on example 1 before we flip the page. Here we go. There's more. Now, this one is not the extra difficult type. It's more of a practice problem. So please see if you can make it this far on your own. Try to do S4 and populate the 3 boxes on your own and try to factor. So I'm asking for 1, 2, 3 lines of algebra. Please attempt to complete all 3. And as I tour the room, I'm just going to pause the camera while you work on those 3 lines. Welcome back. Welcome back to Wheaton Academy. I hope the y minus 4 equals x squared minus 2x went okay for you. Who'd like to give me the triplet of numbers that populates the 3 boxes? Volunteer to give me the triplet. Sarah, you have it? Go ahead.
Negative 2.
Negative 1. Negative 1 squared is positive 1. That's correct. Thank you, Sarah. So, when you, in fact, that's just a signal that you're going to add 1 to both sides. Whatever the third box is. So when you add 1 to both sides, I hope you come up with y minus 3 equals x squared minus 2x plus 1. Any questions on these first 2 lines I asked you to generate? All right. Who's got the factored forms that's set equal to y minus 3? Peter, do you have the factored form?
Is it y minus 4? I had y minus 4.
Well, the thing is, when you add 1 to negative 4, you get negative 3. So when you're factoring, nothing's going to change on the left. It's only going to change this trinomial. Who thinks they have it? What's the factored form of x squared minus 2x plus 1? All right, Shane, go ahead.
Is it x minus 1 squared?
Yeah, it's x plus box 2, x minus 1 squared. Now, you might be thinking, why should I believe you, Mr. Royce? How do you know that box 2 gives you the factored form. Look, if you don't believe it, you can check it out. You can take x minus 1 squared, which is x minus 1 times x minus 1, and use the FOIL method. Firsts, outers, inners, lasts. It really is x squared minus 2x plus 1. It's not just do it because I said it's true. It actually is true, as can be verified by going backwards. So, we should be able to sketch the graph now with the vertex located at, and Haley, once again, I want you to give me the vertex.
Oh boy. 3, comma,
3 is one of the coordinates.
-3.
You know, I say 3 is one of the coordinates, but it's not the x coordinate. The x coordinate is near x.
1, comma, -1.
It's, okay, you know what? Here,
3.
well, one thing I can do that might help you out. That might help you. You can view this through the lens of y minus k equals x minus h squared. So when I'm asking you for the vertex, I'm really asking for h comma k. So h will be following the subtraction sign next to x. So you can see that h is 1 and that k is 3. So it's 1 comma 3. Does that help?
Yes.
Yeah, okay. So again, you were absent yesterday. It's really tough to learn 2 lessons in one day. You're doing a great job. You've got a vertex at 1 comma 3. Since a is 1, it's just over 1 up 1, over 2 up 4. 2, 3, 4. All right, do you have any questions on example 2? By the way, what if a had been 2 instead of 1? And instead of over 1 up 1, we would have gone over 1 up how far? If somehow a 2 would have ended up here, it would have been over 1 up how far? Class? 2 is correct. Over 1 up 2. And instead of over 2 up 4, it would have been over 2 up how much? 8 is correct. So, I mean, it wasn't, but it will be pretty soon. Yes, question?
I'm kind of confused how you got the -1 on the
Right here?
box. Yeah.
This second box is always half of the first box. So whatever you have in the first box, and again, the first box is always the value of b. I mean, we got tripleted numbers here in first standard form. A was equal to 1, b was equal to -2, c was equal to 4. Whatever b is gets deposited in the first box. Whatever's in the first box, cut it in half. And the third box is always the second box times itself. Okay? Now, here's one for you to practice. Please try example 3 completely on your own. I'm going to pause the camera. We'll be back in a second. All right, we're ready to go over this one. Unfortunately, the numbers are too big for the grid. They overpower the grid. I would recommend that at this point you just take your stylus, change it to white, and pretend that you've decided to start over. You have a beautiful landscape picture that you've labored for weeks, months to generate. You said, you know what? I can do better with a blank slate, a blank canvas. So select the white and lock it down. And here we go. I'm hoping that you decided to add 6 to both sides. That's right, y plus 6 is x squared plus 8x. What triplet populates your 3 boxes? Help me on that one, please. All right, Haley.
8, 4, and 16.
So we're going to add 16 to both sides. 22 equals x squared plus 8x plus 16. And using box 2 as an aid to the factoring process, got y plus 22 equals the quantity something squared. What's that binomial in there? So you can volunteer for that one. What goes inside? Alex, do you have it?
X minus 4.
Yeah, it's actually x plus box 2. X plus box 2. So it's going to be x plus 4. So that's good enough to get a vertex at -4 comma -22, which would have been a pain if we had that grid. I mean, we could have So instead of going by ones, we'll go by fives or something. But the best thing to do here, I think, is to just call it a vertex at -4, comma, -22. And we do know the y-intercept is -6. So with a vertical asymptote at x equals -4, we can reflect -6 to the other side of the axis of symmetry. Let's call it -8, comma, -6. We have a parabola that opens up. Any questions on example 3? Oh, you're doing a great job, by the way. And let's go to the next page. This is where the difficulty level shoots up a little bit. This is going to be, there's some potential bumps in the road here. This is not easy to explain. It's not going to be easy for you to do, but I believe that each and every one of you will master this challenging concept. Here we go. All right. Artists, math artists, are you ready to roll? Here we go. Okay. Now, for starters, fortunately, it's just like before. We'll get that 3 out of there. Let's subtract 3 from both sides. 1 plus 3, x squared minus 2. Okay. Now, I noticed that this problem is different than all the other ones. All the other ones just had a 1 out front. When there's some number other than the number 1, you need to factor it out. It'll end up being our a value. So when I factor that out, and technically it's a different kind of factoring. It's called greatest common factor, but don't factor out the negative x. We're just going to factor out a -1. So hang with me here. Admittedly not easy, but when I factor out the -1, what remains in parentheses? Anyone want to tackle that one? Well, no, you're making it too hard. It's not that hard. Serena, do you have it? Okay. Anyone want to give us a go? Carl?
X squared minus.
Close. It's really just x squared plus 2x. Because if you were to distribute the negative sign, it would get you back to this line, -x squared minus 2x. So that's the first move. So if a is not equal to 1, then you have to factor out whatever a is from the first 2 terms. Now let's populate our boxes. We got b is 2, half of that is 1, square it to get 1. Okay, now for the part that requires some real dedication in your imagination. Friends, think of a pan balance. A balance that's kind of like, you can put 5 pounds on one side, 5 pounds on the other side. But if you add a pound to this side, it's off balance. If I add weight over here, it goes out of balance. An equation is like a pan balance. It's supposed to have equal weights on both sides of the equal sign. So when I add 1, x squared plus 2x plus 1, when I make this a perfect square trinomial, what have I added to the left-hand side of the equal sign? It looks like I've added 1, but it really is not a 1. That's not a 1. I've added -1. I mean, isn't this 1 something that's going to get multiplied? So really what I've done is I've added a -1 to this side. I can balance that out by adding a +1. Wouldn't that balance it to the same side? I mean, when it comes to balancing equations, there's 2 things you can do. You can add the same thing to both sides. If I add 5 here, I've got to add 5 there to balance it. Or another way to balance an equation, if you decided to mess up an equation by adding something like y plus 8 equals x. If that's an equation, wouldn't it still be an equation if I add 4 and add -4 to the same side? Yeah, I could either add 4 to both sides, it would be balanced, or I could add 4 and then subtract 4 from the same side. And that's the concept that we're using here. By adding 1, I'm really adding -1 to the right-hand side of the equation. So to balance out a -1, I add a +1. So what we're going to do here is two things at once. I'm not only going to factor, I'm also going to subtract 1 from both sides. I want to factor this, then subtract 1, so that my vertex form is y minus 4 is negative factored form using box 2, x plus 1 squared. And that's a really nice form because you can harvest the vertex right off of there. What are the coordinates of the vertex of the graph of this equation? If you said -1, 4, that's correct. So -1, 4, 1, 2, 3, 4. And because a is -1, it opens down. Over 1, down 1. Over 2, down 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, piggyback 5, 6, 7, 8, 9. We got it. So that's the hard part. I'd like you to practice it. This process is not easy. But for practice, here's what I'd like you to do. I'd like you to, on this example, subtract 10 and then factor out the number 2 before you get to your 3 boxes. So would you please try to fill in all 3 lines of algebra on your own? If you get stuck, you can peek up here because I'll be moving along. Just going to factor out A, factor out G. When you populate your 3 boxes, check up here to see if your triplet matches my triplet. So now for the hard part. When I add box 3, what do I do to counterbalance that? That throws the equation off balance. So what can I put up here to balance it, Haley?
Factor and subtract. Oh wait, I'm sorry. Plus 2. No, 4.
Well, remember by putting a 4 here though, I've really put in 8.
Okay.
I put an 8 on this side, which throws it off balance. Now this side is now 8 pounds heavier than the other side.
You need to subtract 8.
You need to subtract 8 or add a -8. So if I'm going to add 8, I can subtract 8 from the same side to keep it balanced. So now we're going to add 8 and factor all at once. Okay. And utilizing box 2 for the factoring process, I believe the final answer is going to be y minus 2 is a equals 2 times 20x plus 2 squared. Raise your hand if that's the answer you came up with. You're able to work it out on your own. I'm delighted to see that several of you were able to pull that off. Please sketch the graph of the parabola whose vertex is at -2, 2 with an a value of 2. Which means we're going over 1 up 2. And instead of over 2 up 4, it's going to be over 2 up 8, which takes us off the grid. So really, we're done after you go over 1 up 2 from the vertex. Well, there it is, ladies and gentlemen. That completes what I think was a lesson that's a little more challenging than most. Thanks for hanging in there. The homework is is a 2-page worksheet, which I'm gonna post in the Unit 5 section, like, right now. So it'll be on there, so you can do it online. It's an online submission for Monday.